So population by income is joined. I'm going to open up my US county shapefile to see what it looks like in the attribute table. And you should see that, yep, we have the R for the race table, the racial information table, and then we have I for the income table. And so what we're going to do is actually save this as a new file because it's all stored in virtual memory right now. And I want it to be stored as a new file, so it's all kind of on the hard drive as one thing. So to do that, we right-click, if you can remember, the layer that we want to kind of create a new shapefile from, and we say Save As. I can say Save As, and then Esri shapefile, that's the default, that's good. Go to Browse, and what I'm going to do here is save it under my workshop folder and call this Joined Counties, like that. You can call it whatever you want. Just make sure, again, that you never use spaces, always use underscores, and you don't want to use any of kind of these symbols, the odd characters, so don't use any of those, but name it whatever you want. So I say save, I'm happy with that, say OK, and it should come through here as a new file. Alright, it took mine a little longer because I think my computer's tired, but it shouldn't take that long, but mine took a little bit of time. I'll remove the old file, I don't need that anymore. And I can remove these tables because they should be joined all in one new file. So I'm going to get rid of those. Okay. So now I'm going to just go and throw some color on this to see what we've got going on. Just do a total population. And this is where it gets a little confusing. We have to get used to a new window. So we go to Properties. We'll go back to Style, which we should be somewhat familiar with. I'll go to Style, and instead of single symbol, right now the default, of course, is a single symbol where there's a fill color and an outline color. But I want to categorize my symbology by total population. So to do that, I go up to this this bar up here and say I want it to be graduated. Right? There are a lot of different options here. And depending on your version of QGIS, you might have different symbols and a couple of other options. But for choropleth maps, we've pretty much got categorized and graduated, and those are the two most normal types of ways to categorize your polygons for the choropleth. Graduated would be, of course, for quantitative data. Categorized would be for qualitative data. So this would be nominal and ordinal, though you could use graduated for ordinal too. But graduated is going to be for quantities of things, so let's choose that. We get a new thing to learn here, new window, and depending on your version of QGIS, you might see buttons in different places, but just pause the video and explore. It should be just about the same thing for every version. They slowly update it, but so we have to choose the column. It says, all right, you want to do a color scheme. If I just hit apply, everything's going to disappear. I'll show you. Oh no, where did it go? Well, don't worry, it disappeared because we just told it that we want to do a new symbolization, but we haven't defined anything yet. So it just disappeared because here it says nothing represents nothing. So it kind of went nowhere. But if I go to my column here and I say, oh, here's all the information I can map. Let's map the total population, right? R, racial information total. So this should be the total population. And if I hit apply, nothing's going to happen because it says, okay, you told me what information, but you didn't give me any information about how to classify that. So what I'm going to do is say, all right, I want to use a light to dark red kind of classification. So yellow, orange, red. I'm going to just choose this one. And I could hit apply again, but that's not going to do anything because I haven't. It says, yep, you told me the information and the color, but where do I assign this color? How do I give this color kind of classification? So we have to tell it what classes the colors are going to represent. So what I usually do is I go to natural breaks is a good one to start with, and we're going to explore these classifications in a later video. But you go to natural breaks, and it automatically classifies that information into kind of the natural breaks algorithm that we'll talk about, and then you can hit apply, and then here comes in your information. So this is pretty cool, but actually, I'm not that pleased with it because I don't know if you remember, but there's a problem when we're dealing with the fact that there are different sized aerial units, right? Part of the aerial unit problem is that this county is very, very large, and it's just a piece of it is kind of populated by greater Los Angeles, but the whole county is being kind of symbolized as dark, so it looks like it's very, very populated, but really just a corner of it is. So I hope you can get the sense that this is not a bad population map, but we do need to normalize kind of by area to make a population density map. So you can play around with this for a little while. I'm going to go ahead and say that we don't want to symbolize raw population because of the issues like this in Southern California. And, a couple of these larger counties are, Somerset County up here in Maine. That might be, I think that's Somerset. Look at me, a Mainer. I can't identify my counties. I think that's Kennebec and Somerset, and then I don't know exactly what that one is. How embarrassing. So for the rest of the video, I'm going to show you how we create a population density map, and density means per square mile. So I'm going to say OK, and I'm hoping what you can understand is that we need to take that column, population column, and that's this one right here, and we kind of need to divide it by square miles so that we get population per square mile. Now the issue is that we have this shape area right here, and shape area, this is our only measurement so far of kind of the area for each county. And I'm just going to tell you right now that this coordinate system we're in is measured in square meters. And so the default for a lot of shapefiles is they report their area in the unit of the projection that they're in. So you're saying, well, Ben, how do you know that? And I can show you. I don't want you to get too confused. We will learn how to calculate area and more about projections in further labs. But I'll just show you really quick that if you go to the properties of the layer that you're interested in and you go to general up here, it'll tell you the coordinate reference system that the file is stored in. And this is going to look really intimidating, but I don't want you to get upset about it. This is not really code. I mean, it is code, but it just tells you what the projection is. It's Albert's equal area, a bunch of other stuff you don't need to know right now. And then under units, it gives you an M. And the units will always be in meters or feet, almost always. And so this unit equals M means that the units for the projection that our map data is in meters. So it would say FT here if it was feet. So we know that our area column is actually recording, sorry, I'm moving kind of fast here, hope you can keep up, is recording the area in square meters. So not only do we need to divide total by area, we probably need to do a unit conversion to change this from square meters to square miles. So let's go ahead and do that. To create a new field that shows people per square mile, we need to edit our table. And it's good practice whenever you make changes to a table to just go over here and say toggle editing. And when I do that, again, don't be alarmed that the shapefile looks like it's catching on fire. It's just showing us the vertices in case we decide we want to edit them. But we don't. We want to just add a new field. And this abacus icon over here is the field calculator. And this is where we do a lot of this is where a lot of the magic happens for vector attribute tables, attribute work. So go ahead and click that. And we get a new window, but you should recognize this. I think we used it. We used something similar when we made a selection in the first workshop. But we want to create a new field, and I'm going to call this field pop dense for population density, and we want it to be real. Right here's the three principal types of data types. We've got string or text, real, which means we have a decimal, and then whole number, which is integer. And I want real, but I know that the computer will spit out tons of numbers, but I really just want to have 2 decimal places. I think that's plenty. I don't think we need any more than that. And that's what precision means. It means how many significant digits after 0 are you going to allow for. And just because I'm giving it 2 significant digits, it's not, sorry, 2 decimal places, it's not necessarily going to be meaningful in every single county, but we can talk about that another time. The output field width, this is how many digits do you want me to store. I think 10 is plenty. That's, I don't think we're going to have any counties in the, above 1 million square miles or anything like that, so we should be fine. So now how do I get what I want down here? Well, I go to fields and values, right, because we're trying to manipulate the fields. And I'm going to say I want the total population divided by, and order of operations, I shouldn't need to put parentheses in here, but I'm superstitious about how computers work sometimes, so I always keep operations together, because I'm going to take my shape area and I'm going to divide that by a unit multiplier to get my kind of number of square miles per meter. So there are many ways to do this, but you really can just go to Google and say, how many square meters in 1 square mile, and it should come up with this and say, well, geez, there's of course this kind of is obnoxious that it gives us the scientific notation, but if we look down here, we should be able to find right here, how many square meters in 1 square mile? 2,589,988. So let's take this number right here. That's what we want. And it's a little bit more exact than 2.59 with a bunch of zeros behind it. So let's take this number, 2589988. And if every square mile has this many square meters, we should be able to divide our number of square meters by this many to get a count of how many square miles. So if you need to help with your kind of unit multipliers, go ahead and Google that and figure that out. But this is the correct conversion from square meters to square miles. And so it gives me a little output here. It looks like there's a very small county that it's helping me preview. But this should... Oh, sorry, that's already a density value. So that's people per square mile. It's a very sparsely populated county, somewhere in the Midwest probably. All right, so that should do the trick. Let me just make sure I've got everything I want. Create new field, pop dense. It's going to be a real number, pretty wide, just because we can, and then with 2 decimal places. And I'm going to say OK. And it will take a second. But if it came through properly, at the end of my attribute table, I should have pop density. And here we go. It came through. We now have a figure for population density in people per square mile. So that's pretty cool. Let's go and symbolize that and see what that looks like. Don't forget to hit Save Edits. And don't forget to toggle editing off again. Okay, let's go symbolize that. Close my attribute table. I'm going up to my properties here. And style should be the first thing to open. It isn't, but here's the style. And now we can use a new field that we created, pop density, right here. And if I hit apply, it's not going to do anything because I need to kind of symbolize this, and I still have my old symbology here. So I say that's what I want, but then I actually have to hit classify, and I don't know if you saw that, but it kind of took the new data set and reclassified it because the new data is that column, population density. So now if I hit apply, it's a very different looking map, much more kind of muted. And we're going to play around with classifications and symbology in the next video, but I hope you can see the difference that now that we've normalized for area, the nature of what we symbolize has changed pretty dramatically. So I'll see you in the next video about classification.